Okay, so in this video, it says find the formula of a toolkit function, and it's undergone either a stretch or a compression. So in this example, here's the function. That's the toolkit function. So we look at it and we look at the picture they give us here. Now this is g of x. Does it look like the traditional, the toolkit function x cubed, the cubic function? Is that being stretched or is it being squished? Well, you could graph that toolkit function just right here real quick. This might be helpful. Well, it kind of goes up here, right? Okay. And then it'd be like down here someplace. Okay, so I've graphed f of x. So does it look like it's stretched or compressed? Should look like a compression. Okay, but now we want to know exactly what we think that compression is. Okay, if you'll remember up here, that point is the point 2, 8. If I were to put in 2 for x into f of x now, I'm saying this is f of x, I would get out 8 because 2 cubed is 8, right? Okay, now let's see what happens on this blue graph. It looks like the point 2, 2, right? Okay, so what did I multiply 8 by to get 2? See, I'm going to take this output and I'm going to multiply it by something. I should put the letter C in there because the x might be confusing to you. It's not x, it's C. We're trying to find that constant, right? Okay, so I'm multiplying times some constant, that output, and I want to get 2. How do I know I want to get 2? It's this 2 right here. That point right there is 2, 2. So I'm keeping the input the same, but the output is changing from an 8 to a 2. Okay, divide both sides by 8, and you get what? C equals 1/4. Now, you could check other points to see if that looks reasonable, now here's a point right there. Does it look like that's 1/4 of 1? See, the original function, the toolkit function, that point right there is 1, 1. But now on the compressed one, this point right here, I'm saying, well, that would have to be 1, 1/4. Does it look like that? Hopefully it does. I've kind of written all over it, but you can look in the book. And so then we have found what C is. Now we can relate this new function, g of x, to f of x, and find a formula for g of x. So g of x in this case is going to be 1/4 of f of x. So that's the constant we're multiplying by. Now if you're asking, well, why didn't you check any of the negative inputs and negative outputs? You could do that as well. I just did a couple. All right. Notice that the 0, 0 stays put. When the output is 0, it's going to stay 0 because 0 times, a constant is still going to be 0. So that's something to look for when you're looking for these compressions, is anything on the x-axis is going to stay put. Okay.